Okay, welcome everybody to the last part of this cognitive psychology lecture on short-term memory. And now we will look at verbal short-term memory in a little bit more detail. So when we go back to the models we have discussed so far, then in Baddeley's model, they specified that the phonological loop is the verbal short-term memory and stored here, while in the Atkinson and Shiffrin and Cowan's model, the verbal short-term memory is not a dedicated extra store, but is part of a store which is the same for verbal and spatial and object information. Okay, when we look at the verbal short-term memory, I would again like to start with a demonstration. You don't need to write anything for that one. Okay, so I will tell you a number and I would like you to try to remember that number and until the time I say, oh, actually you can use something to write it down. Okay? And let's wait. The number is 52791. Okay, please write it down. Or if you don't have anything to write, say it again. It was 52791, I think. Okay, second demonstration. I will show you a number and try to remember it, okay? Okay, so write down the number. The crucial point is now not about how well you remembered the number and whether you were better in one or the other one. The question now is, how did you do the task? Usually we don't really use introspection as a means in scientific research, but in some instances it can be quite illustrating. So, in the first demonstration, when you heard the numbers, you probably rehearsed them by verbally saying the numbers mentally over and over again. 75921, 75921, 75921, 75529. And that's normal. Virtually all of us do that. The interesting bit is, in the second demonstration, where you saw the numbers, you probably did the same thing. It's unlikely, very few if at all, any people do it that way, that they kind of try to store or rehearse the visual picture of the numbers. That's an uncommon strategy. It's just we say them again, over and over again. And this illustrates that verbal information is encoded in the format of a series of sounds, even when they are presented visually. So that's a key information. This is also called phonological encoding of verbal information. Despite this more anecdotal, introspective approach, there is proper empirical evidence for phonological encoding of verbal information in short-term memory. And a study by Conrad is quite interesting here from the early 1960s. And they did two studies. In the first study, participants were given spoken letters, and when they were presented, there was quite a bit of background noise. And participants had then to recall these spoken letters. And this background noise usually leads to errors. And when letters sound similar, they were often confused. For instance, M and N, B and P. And most of us know that if we try to spell something over the phone where the line is not the best, then it's often like, is that an M or an N? And we revert to these spelling alphabets like Mike, Echo, Lima, Alpha, exactly to avoid that. Okay. That so far is not a very interesting result. interesting bit is study 2 he did. Here he presented letters visually and had a retention interval without the letters, and then they had to be recalled and written back. And he observed a similar type of error, that letters which sound similar, like M and N and B and P, were sometimes confused in this task, although the presentation was absolutely unambiguous. It was clear which letter it was. And the interpretation of that finding is that it's just the noise in our head. If we go through that in an acoustic fashion in our head, we may confuse it ourselves. M and N sound similar. And so acoustic confusion, this is called the acoustic confusion effect, supports the idea of phonological encoding of verbal information. Okay, so if we have our verbal store, then the question is, how many items can we actually, how many words can we remember? And I know that we started this lecture with a chunking hypothesis, and this is now a slightly different angle, but we will come back to that in a little bit. I would like you to do a task again. So get a sheet of paper and a pen, and I will present 5 words, and please try to remember them in order. And when told to do so on the screen, then please write them down. These are the words. They will disappear in a moment. Okay, keep remembering them. Now you can write them down. Okay, so these were the words. You can quickly double check how you did on this task. Another demonstration. Again, 5 words in order and same as before. Keep remembering, not writing down yet. Now you can write them down. Okay, these were the words, so you can double check. Yeah, in both demonstrations there were 5 words. However, most likely you found one task harder. And try to think of why you found that one harder. Well, it's probably the one with the longer words. And this is the so-called word length effect, which was first described by Baddeley in 1975. And this means that if it takes longer to say words or items, then we can remember less items. And the reasoning behind that is that verbal short-term memory has a time limit. And we had that in the last part. Baddeley suggested around 2 seconds. So anything we can say and acoustically rehearse within these 2 seconds can be stored in long-term memory. If it takes more than that, then we can't store it. And that's the reason why the first 5 words were easier to remember, because they're easier to say within 2 seconds, and the second 5 words are much harder to remember, because we have to really squeeze it into the 2 seconds to be able to go through all of them, because they're just so long words. Okay, so it's like that. It's quite interesting and that a cultural bias or cultural effect comes in here. So when you test short-term memory for words, for instance, then you may find on average, if you just take random words, better performance of people in some countries which have rather short words than in other countries where language just created longer words for things. It also shows for instance, when people have to memorize numbers in Welsh or in English, because in Welsh they take a little bit longer to pronounce, you can see that they have a lower memory score. Of course, I deliberately say memory score. Their memory is not worse or anything. They're not less smart or anything. It's just this limit of around 2 seconds which kicks in, which prevents them to remember more numbers in this instance, because they take longer to say. In terms of items which take that duration to say, it's the same across all countries. So this is a good example where one has to pay attention to make sure that research is culturally neutral. So what is our STM capacity? Baddeley says everything we can say in 2 seconds, and Miller said 7 plus minus 2 chunks. And what do you think is right? Think about this for a moment, because on the first sight it doesn't seem to really fit into, or it's hard to see how they both could work at the same time. However, that's what seems to be the case, that both mechanisms or both limitations are at work. And in the Gobet textbook, this Zhang and Simon study is described in a little bit more detail. I don't want to go into too much detail here because it's a bit of a complicated study. In brief, what they have shown is that the number of chunks and at the same time the number of syllables within each chunk determine the capacity. And they took the number of syllables as kind of information, amount of information. So that means if we make bigger chunks, so words with more syllables which take longer to say, then we see that we indeed can recall less chunks because they are longer to say. But at the same time, this effect is not as strong as fully predicted by this time limit. But at the same time, if we increase the size of chunks, then in an absolute sense, more syllables are recalled. So more information if you define information in terms of syllables. Okay, so if you have any question, post them on the respective BBL page, discussion forum. And this was the lecture for this week on short-term memory. And next week we will speak about long-term memory and learning. Okay, thanks for watching and see you soon.